Hello, class. This is a recording on how to find the key characteristics of rational functions to prepare you for our test. Now, this video will show you how to find the key characteristics, but it does not address factoring or any special cases. Just a suggestion. I strongly recommend that you do things in this order. That first, you find horizontal asymptotes, then the y-intercept, and then you factor. After you factor, you're going to find holes. You're going to cancel out the holes, then find x-intercepts, vertical asymptotes, and the domain and range. Now you see that little stop sign symbol? That means if you want to take notes, you should pause this recording and take notes. Now let's talk about how to find horizontal asymptotes, since that's first in my suggested order. You will remember the rules that if the degree on the bottom is bigger, then the horizontal asymptote is always y equals 0. And don't forget to write that as an equation. Asymptotes are lines, and so they must be written as equations. For example, in this example, we see that the degree in the denominator is 2. The degree in the numerator is 1. If there is no exponent on the variable, then it has an exponent of 1. Therefore, this horizontal asymptote is y equals 0. In the second example, we see that the degree on top is bigger. In this case, there is no horizontal asymptote. And if the degrees are equal, for example, if it was x squared in the numerator and x squared in the denominator, then you take the leading coefficients of the leading terms and you divide them to get the horizontal asymptote. The example that I use in the rest of the video is this case. So this is the rational function that we will be using for all of our examples. No need to copy that down. You can copy that down later. So first, we're going to find the horizontal asymptote. Now, the degree in the numerator is 2. The highest exponent on top is 2. The highest exponent on bottom is also 2. So they are equal. So we will find our horizontal asymptote by taking the coefficient of x squared in the numerator and dividing that by the coefficient of x squared in the denominator. So we end up with y is equal to 2 over 1, or y is equal to 2. Next, we will find the y-intercept. Now, to find the y-intercept, we take advantage of the fact that x is always 0 at the y-intercept. So it's just a simple matter of substituting in 0 every place we see x and then finding the y-intercept. So you see here, I substituted in 0 for x and calculated what was left. And what was left was 4 over negative 6, which reduces to negative 2 over 3. And so our y-intercept is negative 2 over 3. Now don't forget to write that as a coordinate pair where x is 0 and y is equal to negative 2 over 3. Now it's time to factor. Now I didn't show you how to factor this here. I just factored it for you to save time. So now it's time to find holes. Holes exist where we have a factor in the numerator that's the same as a factor in the denominator. And here we see we have x minus 3. That represents a hole. We will take that factor, set it equal to 0, solve for the variable, and that represents our hole. So our hole for this function is at x equal negative 3. That means that if x is negative 3, this function does not exist at that point. Okay, now this is very important. Before we do anything else, we need to cancel out the wholes. They are called removable discontinuities because we cancel them out before we do anything else. When we cancel them out, we're left with this rational function, 2x minus 1 over x plus 2. Now we're going to find the x-intercepts. Now x-intercepts are found where y is equal to 0. The only way our function can be equal to 0 is if the numerator is equal to 0. So we will take the numerator, set it equal to 0, and solve for the variable. We need to do this for each factor found in the numerator. Don't forget that there could be more than one. In our case, there's just one. So we set it equal to 0 and find our x-intercept at 1/2. And again, this is a coordinate point, so we write this as a coordinate point, 1/2, 0. Let's get on to vertical asymptotes. Vertical asymptotes are found where the denominator is equal to 0 after you remove the wholes. Now we only have one factor in our denominator. If there was more than one, we could have more than one vertical asymptote. So don't forget to set each factor equal to 0 in the denominator and solve it for the vertical asymptotes. In our case, our vertical asymptote is x equal -2. Remember, it is very important to write this as an equation since asymptotes are lines. Last, we'll find the domain and range. Now, this was a common mistake on your homework and on the quizzes. The domain will be all real numbers except the domain restrictions. On our homework and in class, we called those points of discontinuity. They include both wholes and vertical asymptotes. In our case, our function had a whole at x equal 2 and a vertical asymptote at x equal -2, and so we write our domain as x is equal to all real numbers except with the restrictions of a -2 and -3. The range is always associated with the horizontal asymptote. We know that our horizontal asymptote was y equal 2. And so again, our range is y such that y is equal to all real numbers with the exception of 2, -2. Oh, I'm sorry. That should read 2. There, that's a mistake. It should read y not equal to 2. Right there. Now that's the end of this video. I hope you got some good notes. Look for more complicated examples in your review and on your quizzes.